Hey guys, how's it going? In this video, I'm going to go through this Leetcode number 2, adding two numbers. So we are given two non-empty linked lists representing two non-negative integers. So this is condition is important that handles a lot of edge cases already. So the digits are stored in a reverse order, and this is another important condition that will help us to solve this problem. And each of the nodes containing one single digit, and adding two numbers return the sum as a linked list at the end over here. So in another condition where it says that you may assume the two numbers do not contain any leading zeros, so we don't have to deal with this edge case as the number of zero itself. So let's look at an example right here. We have a linked list number 1 and linked list number 2. 2 to 4 and 2 3, and this linked list representing the number 342. And why 342? And that is because the digits are stored in a reverse order. That means that the last digit over here, the 2, that will come to the front because it's in the reverse order. And then 4 and then 3, right? 2, 4, 3. Same idea for the other linked list of 5 to 6 to 4, and that represents 4, 6, and 5. And we add this number together, we will get 807, and that can be represented by another linked list, which we will be returned, which is 7, the first digit at the end, and then 0 and 8 right here. And then they provide two additional examples, same idea. And then just we have some constraints over here. Yeah, so let's look at how can we solve this problem. And the fact that it's the digits are stored in the reverse order, that can greatly help us to solve this problem, because we can simply just use the sum of these two numbers directly and then construct a new linked list at the end. Let me show you how that can be done. And first, we have to extract the number, for example, 342 from the first linked list. And how we can do that is like this. As you can see, this is how we can get the first number. So the current pointer is point to the linked list number 1, and the number 1 over here, now we set it, we initialize it as a 0, and also we have the position pointer at the beginning is point to the 0 position. So this current pointer points to each of the nodes that we're moving forward. So while the current node is not none, right? And then we have a num1 here that collects all the numbers, and at the same time, if we are collecting all the numbers, we will move the digit each time. So that's why we have to 10 to the power of the ith position. So for example, the first number is 2 right here. So I is 0. So this term is just 1, right? So, and then 2 plus 4 times 10 to the power of 2. Oh, sorry, 10 to the power of 1. So it's 42. And then move forward again, one digit. So it's going to be 42 times 3, 42 plus 3 times 10 to the power of 2, right? So because we moved the position 1 at a time. And then also we have to move the current pointer for the nodes right here. So at the end, at the end of this for loop, while loop, we will get this digit 342. And then we have to apply the same idea to get the second number. So this is exactly the same logic, but we just, instead of list number 1, we're getting for list number 2 right here. So at the end of this while loop, we will get the number 465. right here. So, and then we can just simply sum these two numbers over here, just simply like this. I call it remainder, and then because we will, I will explain to you why I call it remainder. And you see the following. And now what we want to do is to convert this 807 number back to a linked list, right? So how we can do that is the following. So first we have a dummy node which points to the head of the list that we want to return, right? So we initialize it as a value -1 over here. So the current pointer points to dummy node, and while the remainder is still greater than 0, right? And then we do the following. So we basically need to extract. So for example, we are given this number 807 over here. That comes from the remainder, right? So essentially, we want to extract two parts out of this remainder. One is just the digit 7. The other part is another digit, which is A0. Let's say 80, right? So how we can do that is the following, that we can just take a integer division. So 807 do an integer division of 10, so we will get 80. And also 800 at the same time we do a modular, so 807 more modular of 10, we will get 7. So this is how we can extract these two components out of the remainder of 807. So the current digit that get extracted was 7 right here. So basically we do this operation over here, modular. And then the remainder, again, so this is why I call it remainder, because now what is left is just 80 right here, right now. So that's why I call it remainder. This is how we move forward for the next extraction. And at the same time, don't forget that we have to construct a new linked list, right? So I call it the new node. The value is equal to the current integer, current digit, and also we move forward, right? So the current dot next. So initially the current is just a dummy node, and the current dot next is equal to the new node that we just constructed, and then we move forward, right? So the current node is going to be the newly constructed node, right? And this for loop goes on, right? So the remainder now is only 80, right? But it's still greater than 0. So we will do such operation. Take the integer division and also the modular, and move forward until when? Until the time when is 0, right? And then we are done. So at the end of the day, oops, sorry about that. So at the end of the day, we will return a the dummy node dot next right here, right? And that's it. So the dummy node is right somewhere right here before the 7. So dummy node dot next is going to be the 7, right? However, don't forget about one edge case where it can be num1 and num2, both of them are 0, right? It's possible, right? So we have num1, the list 1 has only one node, which is 0, and list 2 is only one node as well, which is also 0. And if that happens, this while loop will go on and on. Sorry, not on and on. This while loop will not be executed at all, because the correct answer should be if num1 and num2 is 0, right? So the remainder will be 0, right? So this 0 is not greater than 0. So this while loop will not be executed at all. So we won't do anything, right? So that is the just one and only one edge case that wasn't handled by this logic over here. And the way that we can handle that is the following, right? If the remainder is 0, that means both of them are 0, right? Because all of them are non-negative, right? So if the remainder is equal to 0, so we just return a list this node of 0, right here, and that's it. So let's submit that. Yeah, it works. And for time complexity, it's going to be big O of n being the number of nodes for list 1 and list 2 together, because we have to traverse the two linked lists together, and at the end we have also construct a new linked list, and that takes another big O of n as well. So for space complexity, if we don't need to consider the space for the answer, the space is gonna be O1 because we just need some pointers here and there. And yeah, so this is my solution. I hope this is helpful. Thanks for watching. See you next time.